Today we are going to be working with the function f of x equals 1/2 times quantity of e raised to the x plus e raised to the negative x, where x belongs to all real numbers. In the first part, we are asked to explain why the inverse function does not exist. We can do this by simply graphing the original function, and then if we take the inverse function, which is a 90-degree rotation of the first function, we see that it does not pass the horizontal line test, meaning it cannot be a function. In the second part of this problem, we are asked to show that the equation of the normal to the curve at the point where x is equal to the ln of 3 is given by 9x plus 12y minus 9 times ln of 3 minus 20 equals 0. To do this, we will need to start by taking the derivative of our original function. So, we can find that the derivative of 1/2 times the quantity of e raised to the x plus e raised to the negative x is equal to 1/2 e raised to the x minus 1/2 e raised to the negative x. From there, we can find the slope of a tangent line given by this equation. All we have to do is plug in our x value, which is given to us in the problem, ln of 3. So, when we plug in ln of 3, we find that 3/2 minus 1/2 times e raised to the negative ln of 3, 1/3, we find that our slope is equal to 8/6 or 4/3. However, we have been asked in the problem to find the normal, so we need to make sure that we switch our original slope to the negative inverse. So our actual slope of the line is negative 3/4. Then we use point slope form to find the equation of the line. So we take y minus our y value, which we find by plugging into the original equation, and then that is equal to our slope, which is negative 3/4, times x minus our x value, which is x minus the ln of 3. After we simplify and combine like terms, we are left with the equation 9x plus 12y minus 9 ln of 3 minus 20 is equal to 0, which is exactly what we were asked to find in the beginning. The third part of this problem asks us to find the x-coordinates of the points Q and R, which are points on the curve, such that the tangents at Q and R pass through the point 0, 0. In order to do this, we will need to use our slope that we found in part 2, which is 1/2 e to the x minus 1/2 e to the negative x. We are using the points x and then our y value and the point 0, 0. And we will use the fact that the change in y over the change in x is equal to the slope. We set this equal to the derivative that we found in part 2 because we know that that is also the slope. And we know our y value is going to just be our equation from the beginning, while our x value is going to be x. So we find that the slope is equal to 1/2 e raised to the x plus e raised to the negative x minus 0 over x minus 0. We can combine like terms, and we end up with 1 is equal to a very complicated function. So we can't really solve that by hand. Instead, we're going to graph that function and find where that graph equals 1. After finding the points where the graph equals 1, we have found that these points are 1.2, both positive and negative. So we have successfully solved the problem and found that the x value when the tangents of these 2 points pass through 0, 0 is going to be negative 1.2 as well as positive 1.2.